Okay, so this week, for Unit 2, we are going to talk about network-related topics. We're going to look at somehow how network scanning and looking into the networks is going to help you with your pen testing techniques and tools, determining the tools. We'll talk in extensive about different types of sniffers, how to really detect them and how to be able to use them for pen testing purposes. So, um, as I mentioned in the last week, that networking is the core in cybersecurity. So you have to be strong in networking. So I would encourage you to learn networking, also get certification in it, like having a Network Plus is going to help you in this industry because a lot of these things are going to come back to your network systems, your communication systems. So we're going to touch a little bit at the beginning on packet sniffing. Um, Typically, you would use a tool, like a software tool or hardware tool, to be able to sniff out your traffic. A packet is basically, it contains information about what is being exchanged between the systems when it's routing. So that means that if I'm visiting a website, I type in the URL, it's going to have a packet that's sent from my system, right, to the router and then eventually to the external network or the domain that I'm visiting. So everything is very transparent on the network if you're using sniffing tool like Wireshark, right? So at the beginning, it talks about how we would sniff packet, and basically it's a way that we can analyze data. So in a packet, you would have what's called a payload. And in that payload really tells you about the data that's being sent. So let's say that I'm visiting a website and I'm submitting my information to register for an account, right? That information is then being contained in the packet. It doesn't have to be one packet. It can be multiple packets. It depends on how much data that you're sending through from the source to the destination system. So my system is going to be the source, right? And the domain that I'm visiting, that I'm filling out the form, it uses HTTP or HTTPS, and I would be able to submit that. So your system breaks it down into packets, and that's how it's able to transmit your information from your system through the network and then to the external network, right? And so what we see is we would use TCP/IP, and as it talks about here, so in the case that if I'm logging into an account, like to pay my bill, to access Canvas, right, for my school, all of that information can also be contained in the packet. So sometimes an attacker would then take that packet, analyze that packet, and potentially see, right, what kind of information that you have in there. Is it credential? Right. So in my forensic class, I think some of you have taken that. We actually took a capture of the traffic. We pulled down the credential for the user so we can see, right? So in analysis, you would have tools that allows you to analyze the packet. So your login information, your data, it could be encrypted, but sometimes, right, people can strip down the encryption, and they can also use tools to be able to understand more on what you're using. So this is why when you're using Wi-Fi, right, never use important sensitive information on public Wi-Fi because it is very vulnerable, right? Someone can see everything that you do, right? If you're visiting Instagram, if you're accessing your school account, etc. So it talks about that here. And one important thing that you need to know, that it is legal to run a packet sniffer, right? Like Wireshark. But the legality, there's a gray area. The intention of how you use your tool is going to make it legal or not, right? We talked about that last week. So if you use packet sniffing to monitor your network to make sure that everybody is safe, then that's okay, right? If you are authorized to use packet sniffer for pen testing, that's okay. But if you're using packet sniffing to pull a packet and stuff a packet or craft a packet, you can fake a packet, right? To launch an attack, it becomes illegal, right? So the intention of what you use and how you use it, right? If you are modifying the data, that you're circumventing the system, right? That's computer abuse law. So when you go into this area, when you are using the packets for unauthorized access, escalation of privileges, and so on, it becomes illegal. Okay. So there is a gray area in pen testing, and we've got to be mindful of that. So let's go through and answer some questions. So number one, it asks you, why is packet sniffing important in pen testing and network administration? We said that packet sniffing is used overall to determine the weakness or the vulnerabilities of your network. It also is a way that we can monitor traffic flow. It's kind of like putting a camera on the road and you would see all the cars and all the people that go by, right? So in that, I can see how many cars, how many people actually walk on the road. And I can also see, like, is it congested traffic? Is there an accident, right? Or is it fast? So we want to be able to use this tool to make sure that we have proper traffic flow. Now, quality of service is one important area that we focus in networking and in security to make sure that if there's congestion or bottleneck, we want to make sure that we divert the traffic. It's kind of like, you know how they have detour when they block a certain road because of accidents, right? Making sure that you still have flow and you have availability. So traffic flow and performance is important, and you have to troubleshoot in the case that if you have, like I said, latency, delay in traffic, or if you have network issues. So we want to make sure that it is available. So ultimately, the A in the CIA for security is to make sure that your network performance is up to par. And in your notes, right, the first page, I highlighted those bullets for you earlier. It talks about what is legal and what is illegal when you're using packet sniffing. So packet scanning, like using a Wireshark application, T-Shark, and you would see that in the lab today, hopefully, is legal when you're using it to identify, right, problems on your network and your network performance. So if you use it for network administration, that is okay. If you use it to look at how you can better secure your network, that's okay, right? So that's legal. But if you're using it for unauthorized access, packet modification or packet crafting, or data stuffing or data modification in the packet, like I said, it contains the payload, then it is illegal. Now, let's put this into an analogy, right? So a packet is kind of like a shipping box that you send your friend a present. You put your gift inside the box. You put a label on it, who you're sending it to, right? Their address information and your information, who you are sending it from your house or from your address, right? And you drop it off at the post office, and then they would transport that via plane, train, whatever, right, to get it from your house to your friend's house. So the packet would contain that information. In the header, it's going to have, right, the source, which is your house, right? So the system that is sending. And typically you would see an IP address because packet is only used for routing. The router needs an IP address, okay? It needs to know which network it's sending to. It's like the post office. They need your zip code, right? So, and then it's going to have the destination address, which is also an IP address. So it's going to say, so the router, when it leaves your network, when your traffic is going to get to the router, and the router is going to say, oh, this needs to go to google.com, right? So I'm going to pass it to the router for my service provider, and then it's going to pass it forward, and eventually these autonomous system is going to get it to the domain that you need to access, right? That's how we visit the internet. So with that, when you scan a network, when you look at the packet, you're going to see a few things. Who is sending? Who is receiving? What kind of information is being sent, right? Because everything is related to a service. So if I'm watching a video, it's going to show that I'm streaming. I'm using a service, right? If I am playing a game, right? And in gaming, you know that it's going to utilize a lot of the bandwidth. So you have continuous multiple amount of packets. And if you use game that has high visualization factor, your packets is huge. Your payload is a lot, and it's going to break it down to many packets. So it's like sending a big gift, but in many boxes. Okay? And so when it gets there, right, what the system is going to do is the receiving system is going to take all of these packets. Your data is never in order. Okay? So it's like if I'm sending my friend, right, like a bicycle, and I broke it down into many parts and I put it in different boxes, right? The shipment is going to come in various times. I might get a wheel one day. The next day, I might get a handle of my bicycle. So your system, when it receives it receives it in not in order. It's not in order, okay? And then what it's going to do is going to take a look at the header, the checksum to make sure everything is there, right? It's kind of like, oh, the post office check to make sure that your package is not tampered. It's going to take that. It's going to put it back together. It's going to say, oh, the handlebar goes first because there's a trailer. There's information about your data that feeds it back. So this is why when you're streaming or when you're buffering, right, you see the buffer because your packets is not arrived. It's still waiting for the next shipment, right? So you might have that little circle saying pending, the video's queue is waiting, right? Because the packets don't come in order sometimes. Your system is just, its job is just to get the router, it gets it to the fastest place as soon as possible. So you might get something in the later part of the video first, and then it's going to give you the middle part of the video after, right? So this is what you would see. And also, it also depends on your network, their network, etc. So there's a lot of different factors. All right. So now, we talked about packet scanning, whether it's legal or not legal. The notes contain additional details for you, right? You can use a hardware, which is an appliance. Basically, you just put it through. All your traffic is going to funnel through this machine, and it's going to see everything. It's like I said, it's like putting a camera on the road, right? And looking at everybody that passes by. So what we can do is we can use a common tool, which is Wireshark. And Wireshark, if you visit the website, it's free. You can download it. It's considered a protocol analyzer. Another name for it is packet sniffer, right? It's a way that we can capture the traffic. So I'm gonna, if you haven't seen it before, right, I just want to show that, show this. But if you have, right, you can download it and use it. So it is compatible with all OSs. We're gonna use it in Linux today, but I had the IT people install it on your computer. So when you first open the app, you just call up the app. Once you install it, right, you basically type in Wireshark. And the icon for it is the blue fin. So when you click the app open, it's going to look like this. Now, it's going to give you like these little mini graphs. Basically, it's receiving signal on those adapter. So now, in some cases, you would see that a lot of the pen tester, they have multiple adapter. I never do the work with just one adapter because in the case that if you're scanning and you're doing something else, you have options, right? Either you have an Ethernet adapter and a wireless one, or a system that has multiple. It's just part of the job. So, and you want good throughput, so your adapter has to be a good adapter. So it's gonna tell you that these are the adapter. You notice that there's Ethernet, right? There's Wi-Fi. So you pick the adapter that you have installed on your computer. So let's say that I pick Ethernet 2, or let's say the first Ethernet, right? The first Ethernet, so it shows the graph, so it's active, it's receiving signal at the low level. And then you just click the blue fin to launch, okay? I did write a lab section for this part, but because of time and last week delay, right, I cut that out, but we're gonna do something with this later. Okay, so we're gonna click Ethernet, so select your adapter and you just click start. So now I'm capturing, I'm listening on, I'm watching everything that passes by. So you're gonna see a lot because depends on your network. If you do this at home, it's still gonna show a lot, but you only have a limited number of systems. But in an enterprise network, when you have thousands of systems talking or passing information back and forth, receiving and sending, you're gonna get a lot, right? And then once you wanna, let's say I wanna only capture it for a certain amount of time, I can stop it, right? And I can save this file, okay? So in the case that you're getting attacked, if you're running monitoring system, you should see it, right? The denial of service attack is going to give you a flood. It's going to drop from the same source. It's kind of like somebody is dumping all the packages to a certain destination. They're sending like 50,000 packages to that one address, okay? So the packet is going to come across and you're going to see from the same source continuously. You see how this is the source, this is the destination, and this is the type of protocol that it uses. So if I want to look at it, I just double click, right? And then you can break it down and you can see the frame, which is the lower level, right? And it tells you where that's coming from. So that's a Cisco device that's being receiving, and then where it's coming from, which is a Dell system, etc., right? So the data is on the bottom right here. And typically, you're going to see the payload at specific size. So it's kind of like, oh, if I need to send a bicycle, each part has to have a weight limit, right? We can't put it in a huge box because that will cost a lot. So you can put it in the smaller box with the weight limit so it costs less. So the system, it does that. It breaks it down into multiple packets. Any question? So any question? I encourage you to practice using Wireshark. They also have their own certification. There are lots of tutorial online, YouTube, wonderful education materials for Wireshark. So knowing this is great. It looks really good on your resume as well. Okay, so it talks about sniffing, and let's talk about the attack side, right? So when someone is performing a sniffing attack, basically they're just scanning your network. Like for example, I can sit in my car with my laptop and I attach myself to the wireless network and I can run a scan, right? Remember, we talked about legal and not legal, right? So if you are using it in a malicious way to conduct additional attacks, so I can't just scan and call it an attack. It's really just a scan, right? But I can do recon that way. I can find out like what kind of systems do they have on the network. It shows Cisco, what kind of, things are being configured for that Cisco appliance, and so on, right? The service that's running. And so they typically use it for additional type of attack, right? Like ARP poisoning, which is address resolution protocol, or DNS poisoning, right? So typically you would see that it would start with a scanning or sniffing attack. And then once they map out your network and your devices, they will find ways to get in or target specific appliance or systems, okay? All right, it talks about passive and active sniffing. So you can use devices that are connected to your network, or you can also use software. Okay, so the difference between a passive packet sniffer compared to an active packet sniffer is that when you're using a passive sniffing technique, you capture that traffic that the device is connected to, right? Like my laptop is connecting to the wireless network, okay? And I'm running Wireshark, okay? So passive sniffing is harder to detect compared to an active sniffer. So that means that they would need to overcome your security barrier, like your firewall. They would need to add some traffic to the network, right? Like generate their own. And then they need to detect systems. And I said this to my 41A class yesterday. Mostly, a lot of the active service system call home. That means that it comes back to you, right? So it's like you go out to the world and you say, who are you, right? And you're trying to identify the people out there, but in order to get an answer, you have to tell them who you are. So the system does that. It's going to say, I am this IP address, tell me who you are, right? And so in that case, you are visible to the other system. It calls back to you. It comes back home. Okay. So that means that if you can detect them, they can detect you. And anything active scanning is that, right? So if you need to be stealth, then you can't perform active scanning. Okay. Passive scanning is going to then be more stealth, but you're not able to generate traffic. You're just a person that stands on the road and watch everybody goes by. That's basically it. But if you're active scanning, right, you're part of that traffic as well. So I'm basically driving on the road. I'm generating my own traffic. I'm avoiding the police because they might detect who I am. And I'm seeing everybody else that's driving along with me. Okay. Any question? Okay, so this is a base when you are reconning a network. You perform sniffing. Okay. Okay, so before we answer the next scenario, I want to point out, so there are many different types of sniffing attack. You got Wi-Fi packet sniffing. We talked about that. Attach yourself to the wireless network. And basically you can do multiple attacks with that, right? Like I can look at initiation vector. That's going to also help me determine like the Wi-Fi encryption and all of those things. And so from an attacker standpoint, I can also use devices like Wi-Fi Pineapple, scan your network, and take and lure the people on your network to me, right? And then if I don't like them, I can actually gradually pick them up, right? So ultimately, I can run other tools like I can capture their information, I can perform other attacks, but Wi-Fi Pineapple is really designed to become an evil twin. So when you have an evil twin attack, basically it's another wireless access point that is evil, right? So I basically copy everything that you have on your regular AP access point and then trying to get everybody to connect to me. So, and then I would do malicious thing to those people's traffic, right? So that's what an evil twin attack typically is. Then they can sniff out your browsing, your internet browsing, because your traffic really represent which website, which domain you're visiting. And then there are other things that comes along with this, right? Most domains or interactive websites on domain uses JavaScript. This is how you fill out form online, you submit comments. Those things uses JavaScript. And that's different than Java, not the same language, okay? JavaScript is a web-based language. And so in a JavaScript sniffing attack, basically they can run malicious script, right? And to obtain private information. How can we stop this? I emphasize this with all my computer science classes, like programming classes, input validation. So when you assess applications that are web-based, if you control the input correctly, they cannot inject scripts. Okay. So a script needs to run, and in order to run, your system has to receive it. Your server has to process it. So if you control how it can be inputted, right? And so, you can clean that up a little bit. So input validation is a very important criteria for security when you're designing software, when you look at security applications, especially for web app or native apps. Okay. Especially web app because they're very targeted. And we'll come back to some of the additional attack here, but they're gonna sniff out your password. They can look at your session ID and be able to hijack your session. Just for example, if I submit payment, right, online, I will have a session ID for that, right? They can redirect that and receive my information on their server instead of my bank server. And then redirection, usually typically that's DNS, so it can route to their server. You see this a lot with phishing attacks or malware attacks. And then address resolution protocol. So they can change the address to the network because ultimately we use ARP to be able to control, right, to resolve addresses that's coming from a private network into the public network. Okay. I know I'm just trying to give you the sum of network class in a very short time, but like I said, this is important to learn. Okay. And then ultimately also DHCP. So dynamic host configuration protocol, this service is used to lease IP addresses to private systems. So when you boot the computer on the network or when you're logging in and you attach yourself to the wireless network, right? DHCP server at RCCD gives you an internal IP address. When you go home, you attach yourself to your router, your access point at home, it gives you its own IP address range, right? So this is a way that we privately use the IP address, but when you pass the router, when your traffic hits the router, right, it takes on one public IP address, right? Because that public IP address is given to you by your service provider, right? Your Spectrum, Frontier, they give you that one IP address for your router, and your router uses that to pass traffic. Okay, so let's go through and answer the next part. So number 5, it asks you to refer to the below scenario. Determine what type of attacks, the type of attacks can be used for each scenario. So A hacker is connected to the wireless access point and perform a scan on the network. This is considered a passive or a wireless sniffing attack. B, a hacker is scanning the user's network web connection and activities in interactive online forums to obtain private data and credential information. So the key word here is the forms, right? I've told you the forms are usually created using JavaScript. So that is a JavaScript sniffing attack. C, a hacker performs a network scan to get users' ID on an e-commerce website and uses that ID to access unauthorized data such as shipping addresses. That's a session hijack. We'll do something with that later, you will see, right? So that session hijack, basically your session has an identifier, it's a value, it's a string. And so if they capture that, right, in a packet or through browser sniffing, they can pull that and they can impersonate you, right? And so they can access like your payments information, your shipping information, and so on. There are other ways to do, but typically session hijack refers to taking that session ID and use that session ID for the attack. And then D, a hacker sets up a rogue DHCP server. We talked about DHCP server leasing out IP addresses for the connected systems. And when they do this, they would flood the real one, okay, with multiple requests for the IP address to occupy the legitimate server and use packet sniffer to monitor network activity. So those are two things. One is DHCP snooping and sniffing, right? So what it does is it it tries to become the real one, right? But it's a fake DHCP server, and it floods the real one, so you don't know which one. It will take down the real one, and so the fake one will become the server, and they would use that to sniff out possibly activity on the connected system or the leases. Now, this can be detected, right? If you monitoring your network, so in order to create a flood, they have to send continuous requests, right? And if your firewall rules are effective, what you can do is you can, and we'll emphasize this a little bit more. It's very similar to denial of service attack. So you can control it where if you have like 10 multiple packets from that particular source, you need to stop it and analyze it. You can block it and then look at and then authorize it to go through. So on your security management system, what you can do, you can specify it, alert me, right, when I have this type of activity. So in order to flood, they are going to send continuous requests, like, so denial of service is about flowing the resources for the system. So they are going to keep sending requests. So I talk about that in the notes, like Smurf attack and other attack. So you can ping someone to death by just requesting them to respond, right? It's kind of like you have a teacher in a room and there's like 100 kids. Those 100 kids ask many questions at the same time. So the teacher will get so overwhelmed, would not know how to answer. That's a Smurf attack, right? That's a ping attack. Okay, and so for E, a hacker intercepts data packets and sends false messages on the network, redirecting traffic away from the user's IP address to a fake website, trick the user to enter login credentials. So multiple attacks happening here. One is going to be man-in-the-middle attack, because in order to redirect, they have to intervene, right? And then also ARP sniffing, because they need this IP address, okay? And then fake website, that's a redirection, that's a DNS poisoning. Okay, so basically they take the record of your real DNS server and then they modify it, because the DNS record, it's a file that refers to itself. It's a reference file, right? Of domain name and IP address. So for example, google.com is 8.8.8.8. It has that correlation. So if I break that correlation in the file, right, I would say google.com is 10.10.10.10. It redirects it to my server every time they put in google.com, you see? So if you protect your record here in your DNS configuration, you can prevent that from happening. Okay, because the DNS records have the public IP and the registered domain name. Question? This class is highly technical, right? But we're gonna repeat some of the concept over and over again, but it's a very cool class. You're gonna see how we do this, right, in the back scene, and also how the attacker uses the same knowledge and skill to attack. Okay. Any question regarding the previous exercise? So I recommend going through the notes again. You can rewatch the video. So one of the things that I want to point out, so how do we stop this from happening? I already mentioned to you some of the things to combat. The whole point in this class is not about whether you can take down the network or attack the network. It's not about that. It's about knowing those things can be happening to your system and stopping those things from happening to your system. Okay? So one important area, update your software, your firmware, your software updates, right? Even drivers, so those things become vulnerable and they can utilize that to perform different types of attack. You need to make sure that you are detecting and responding, right? But more importantly, proactively understand your security landscape and having the measure to make sure that breach don't happen. Okay. So as a pen tester, you are going to perform attack to see if you can cause a breach and see why that's happening and what we can do to close that gap. Okay. So you simulate an attack and see if you can breach, and then you want to see how you can stop that for someone else if they attempt the attack. You know, MFA is another level in security, right? I know some of you have attended some summit or events that talks about MFA. It's not that strong, okay? MFA is an extra step. So, like I said, in many of my classes, security is about the race between resources and time, okay? So if you can buy more time in something, you can elevate that level to make it more difficult and extend the time, right? You eventually would deter some of these malicious intentions. So multi-factor is good. Now it's widely implemented and we require that for most of our government systems. But there should be more to this, right? I know that we are transitioning to a lot more biometrics based, and our systems are better at image recognition. We're using more AI-centric based systems. However, right, all of those things are templates, and it's stored somewhere. So how do you protect those templates is important. Okay. My dissertation was also on biometrics, so we'll touch back on that. Okay. Security training for the users, make sure they're aware and they have the best practice in place. And then implement virtual private network solutions for connection, especially for your remote worker. I think now, since post-COVID, right, we really welcome remote access and remote working. So virtual private networking, just like anything, you're gonna have products, you're gonna have different ways to do things. Some products are better than others, right? Just like how if you go buy a car, some cars are gonna have more safety features than others, right? Are you willing to do the maintenance or pay the bucks? Okay. So a lot of the times business compensate because of cost. And so virtual private network is the same thing. It is great to use that for personal use. I recommend it, especially if you're using wireless network. If you travel a lot, that's recommended. But with that, there's a cost, right? Okay. So let's go through and answer number 6. So in the next part of the notes, it talks about reconnaissance or recon. So when you are reconning a network, what are some of the steps? And what is the step after the information has been collected to determine the IP address range? Okay. So recon is about gathering information. We emphasized this a little bit last week. Okay. It's about knowing what you're working with, doing the homework, the research. So in a network environment, it's really simple. You just need to know which systems are connected, right? And so if you know the communicating system, then they have to have IP addresses because everything is routed. Everything is TCP/IP. Okay? So if you identify the active system, then you go to the next level, right? Your server, who gives out IP address range. Now, in a private network, you are going to have a group of IP addresses or multiple group of IP addresses. It depends on the design. And when it leaves your router, like I said, it's going to take on the public IP address, right? So when someone is attacking you, your firewall is going to show the public IP because they're coming in from the outside, right? Once they reach your router, right, they have to enter the private network. That's where we're going to have the security guards, the dogs, everything to make sure that it's protected, right? So if you have different levels of security implementation, you would be able to make it harder for someone to find your information. And if they don't find your information, then they're inaccurate and it's harder to perform the attack, right? Attackers, especially when you're looking at nation state, they are invested because there's a lot of money involved, right? Sometimes they're sponsored by entities and they get paid to do it. So in that case, there is a very strong objective, right? Could be for monetary gain, fame, a lot of different things. So let's talk a little bit about this. So these are the basic 7 steps in recon. You need to collect initial information. We did a little bit of that last week. Then once you have that information, you need to determine the network range. You need to identify your active systems, your systems that are connected and communicating, right? So who knows how to do that? How do I know if the systems are connected? I can use software tool, but let's say in command line or command prompt, how do you know? So some cases we can ping, right? We use a service to be able to determine the system, right? You already know that when you hit the router, you're gonna get like 10.x.x.1. That's gateway IPv4. It's typically administration. Because that's the first system you hit, the host number is gonna be 1. So subsequently, they might have a .2, .3, .4 schematically, right? Because network administrator, just like myself, we were trained that way, right? So you have to think like a network administrator to really look at how they design their network, right? So I can ping a .2, a 10.0.0.2, and so on, right? I can also use hping to ping a group, but those are active, so the system is going to listen and respond, right? So if you ping them a lot, it's going to raise an alarm, right? So you can do a group ping, but definitely that's going to raise an alarm. So you need to find access point and open ports. Nmap is really good for that. We're going to come back to lab 1 on that. Open ports tell us what kind of service they're using. It's kind of like you open your garage door so that way people can bring big things into your house, right? They can ship like a refrigerator to your house. You open your door so people can come in. So we open certain ports on system doors and windows for specific things, okay? And those are all numbers. Okay, fingerprinting, we would know the version of the OS because that tells us potential weakness, right? And then we can map the network. Nmap also gives you a map of network. There are others. So 41A class last night, I talked a little bit about some of the tools that can be used. And so these are the goals. You need to get IP addresses, system names, open ports, certificates that are used. That really pertains to access level. Just like you know how on your phone you have an app and it asks you, do you allow this app to turn on the microphone or your camera, right? And you said allow only when using this app. So when you do that, it adds that component to a certificate, which is a file on the system. And so whenever you run the app, it's going to look at the file. It's going to say, oh, I can turn on these hardware devices, right? That's what a certificate does. And we can have a server that handles all of that. So all your credential, all your, how you have single sign-on once you log on to email and you access Canvas, it all refers back to all of that, right? Okay. So there's additional information about some of the things that you need to find. Services, file permissions, trust, server trust one another to exchange data, right? You have to set that up through configuration and then account information. Some of the tools, so I mentioned Wireshark. Metasploit comes with Kali Linux. Nmap, you can run it on Windows, which is known as ZenMap, and then you run it in Linux environment, which we've seen a little bit in Lab 1. That's Nmap, and that is an active recon tool, right? Burp Suite, Cobalt Strike, Beef, these are used for different things. We'll come back to Burp and Beef. I will not be able to use all the tools, right? But I want to share with you some of the main ones, the popular, the common ones. And then the definition for what an exploit is in the next one. So that helps us answer the next question. Number 7. Fill in the blank. The blank is a program that's designed to find and take advantage of a security flaws, such as a vulnerability in an application or a system, typically for malicious purpose. That's called an exploit. Right? You might learn that in 27, CIS-27 or another class. So how can you locate known exploits? Right? We're working with a lot. There might be like different type of exploits that exist. I'm gonna tell you we won't know all, right? But this industry, they're really good at documenting in a database. So there's a repository where you can go and you can find like specific exploit for a certain brand or product. For example, right? Like Microsoft documents their own, but you might go to a database and you want to see if the router at home that you're using that Spectrum loan you, right? Or lease to you that you pay for, is that vulnerable, right? Like a Motorola device or Netgear, whatever, right? So everything that we use has some vulnerability in design. Okay. Period. Okay. That gives us job security, but at the same time, it gives you challenges in your work. So you can go to a database or multiple database for your vendor. You can find the information. By regulation, they must document this. Okay. And they also have to audit. So whether it's flaw in software or the hardware or the firmware, typically for IoT devices, like your smart things, typically that is in firmware issue or software. And then you would see common vulnerability exposure, your CVEs. Microsoft has their own, every vendor have their own. So, and you can also go to some of the main ones like CISA to be able to find that. CISA. Okay. So I shared that information in your notes. Like exploit DB. So if you want to be red team, right? You want to do this, you want to hack for a living, and you want to get paid a lot for it. Offensive security certification is the way to go. Kali Linux offer offensive security, kind of pricey, but if you get good at it, this is what you can do for life. Okay. I'm going to tell you right now, there are a lot of different security professionals in the world, right? Offensive security people are just different in nature. When you go to DEF CON events, when you see those guys demonstrating ATM hack, car hack, those things, Google Nest hacks, those are offensive red hat people. Okay. So you have to think outside of the box. You sandbox a lot of things. This industry requires time. So when you're doing a lab, some of my students are like, oh, I run a scan and it's been like 10 minutes and nothing comes back. Well, there's a lot of factors, right? You have to wait. Patience. So when you look at this database, it's going to give you a lot of exploit information, right? We want to find those things because those things are important for us to build security solutions. Okay, I put the links. And then for Google Hacking Database, that's also useful. You can refer to their database. Rapid7, highly affiliated with Nmap people. And then if you want more pen testing tools vulnerability, the tools that you use themselves have issues, right? And so you can also go there. Mitre, in this, if you want to go to high level security, that's going to be your best friend. They document the tools that they have discovered through different breach and attack, from hardware, processor, all the way to, systems and communication. So I put most of the links there. And then NIST have really great documentation and guidelines. So we refer to that for practices. So if I'm new and I don't know anything, NIST is going to give me some guidance on how to address the problem, right? Like implement encryption, what should I use, stuff like that. And then CISA is run by our government. They document exploitation vulnerability. The funny thing was I was hearing a little bit of news a couple weeks ago. about how CISA has changed its foundation, right? Some of the director left, they hired new people. In that, they also announced that they are getting rid of all their outdated system, they're upgrading, right? Which took, it's not a surprise. You already know public sector, it takes them a while to get their system up to date to the current. So it resolves the problem, and they interviewed the former director. So if you want to work for, agencies and governments, some of the time there's much needed area to be done there too. So, and then it talks about packet storm security. This gives you like historical computer security tools, exploits, and advisories, right? So historical stuff, because things repeat, even though it might change a little bit, you're gonna have like similar behavior and different things. Okay, so for number 9, it says, what website provides current historical computer security tools, exploits, and security advisories? You can go to Packet Storm Security. So these are some resources for you. All right, so let's talk about some vulnerability based on the description. For number 10, case A, Windows Transport Protocol, often used for file sharing, printer sharing, access remote services using port 139. You know how when you're on Zoom and you want to drop a file into the chat box so they can download it? Guess what? That's SMB. SMB has stolen cost. Avoid using it, period. So service message block, right? It uses this port. This is a common port 139. Some app you install uses this service, and it turns on that port. It opens up that window to use, right? So if you want to drop files, like let's say you use a messenger app and you want to share like a video that you created with your friend, right? And you drop it into the chat box, guess what? Right? In Windows environment, it's those things. So we can use it to share files, share printer, access remote services. And that's called SMB. You tend to see a lot of vulnerability with this service and protocol. Number 10B, a client-server model architecture using separate control and data connection for file sharing between client and server. This is known as FTP. We should always use secure FTP, right? FTP in the regular service is not secure. So you see FTP file servers that are available, public ones. This is a way that people can upload their file and download their file. Historically, you can be anonymously using it. You don't have to create an account. Nowadays, even on public server, in order to use that service, they want to have the accountability. They want to track who's sharing malicious file or not. So that's how, so FTP is a service or a protocol for that. And then mail server application used to send, receive, relay outgoing mail to senders using port 25. This is your SMTP. So your Outlook, like if you use your Outlook with your server, which I do to respond to your emails and such, right? That's SMTP. Most companies use that. Windows system that use WINS to translate host name to IP addresses. This is considered NetBIOS name service. So traditionally, this was created for older Windows version. Before IP addresses, your system can only be identified by names, okay? And there's only so many characters that you can use to name your computer, and they have to be unique. It still is. So this is a service that's in the back always for Windows. It's always on. This is how when you type in host name, it's still able to tell you your computer name. Okay. Now, but this correlate your computer name to the IP address once it's connected to a network. Okay. So let's say that I don't use the IP address, I can also send traffic to the host by its name. Okay. Any question? Okay. So where can I find this information? You can find this on page 4 out of the 9 pages. It also talk about link local multicast name resolution. This is for IPv6 and IPv4. This is typically used in place of having a DNS, which is your domain name system. And this was like implemented post Vista, I think Vista and later. And then if you're using Linux, you can use system, right, for LLMNR. And this is used as a temporary network if you have like ad hoc Wi-Fi, such as you see what this ad hoc typically refers to, like near field devices. You know how you have Bluetooth, like let's say your phone, your speaker, and maybe like something else. That's more of an ad hoc network. So you tend to see that in the more like close proximity Wi-Fi based structure. And then it talks about SMB. It also uses port 445 in Windows system. Now, if you look at Eternal Blue, which is an older exploit now, WannaCry ransomware, it utilized the SMB vulnerability. Did you know that WannaCry was discovered by a 15-year-old? Right? The issue? Because and because this particular service exists in Windows environment, right? So it caused a lot of problem for many companies. Eternal Blue exploits also. I think we have it pretty much under control. So this is why your Windows updates are important. I know, right? It's inconvenient sometimes that you have to shut down but updates before that. But you need to push updates. And sometimes updates can cause problem, but we want to make sure that we close out some issues there. Okay? And then I put down some additional protocol. So make sure you know your protocols because it ties to the services. Okay, let's move on. For 11, it says, what type of attacks entail fake information being entered into the cache of the domain name server, resulting in DNS queries, producing incorrect reply, sending users to the wrong website. This is a redirection, so it is DNS poisoning. I talked a little bit about this before, right? Your domain name system has a reference file, and if you modify the reference file, you're poisoning that record. And so it uses that record to correlate its domain information, like IP address, to the registered domain name. And so if you modify the domain name information on the record, you create a poison to the record. So that's called DNS poisoning. And then 12, what method of attacks would consist of adjusting the server configuration and direct the users to the malicious website. It's also considered DNS server hijacking. So often you see these two together, right? So instead of going into the main company's website, we would just route it to a different server somewhere else. So what's the purpose of it anyways? Typically, they use it to steal your data, like credential, access information. They also use it to distribute malware. That's very typical. Also stop security updates, keep your system vulnerable. And then they would use it for censoring web access. So you often see this now with like phishing type of campaign, malware campaigns. Those are very common. Any question? I think we're pretty good on time. So some of these form of attacks, we're going to drill a little bit deeper in the future chapters, right? We'll focus on like injection. We'll focus on denial of service. We'll focus on some of the form of attacks. in the later sessions. But still, like in these classes, they're going to keep repeating the form of attacks because that's what you deal with. Okay, for 14, let's move this down. 14, it asks you in Windows systems, what type of attacks target NT-LAN manager, NTLM authentication system. This is considered past the hash. Some of you know, right? We talked about hash is a way to identify an object in the system, like a file. So when you have an account, that account is considered an object in the system. So when I put a username, right, that's for a subject to log in. But when I create a password, that password is stored, right? Microsoft, Linux, Mac OS all claim that in all OSs, by practice and design, your password is encrypted, okay? Now, a way that a password can be jeopardized is to use this technique, is to use past the hash, or your credential can be jeopardized. So if you're using Kane-enable or a type of password cracking tool, you would see that it also has this option where it does pass the hash because your password is stored with a hash value. NT-LAN Manager is an older service or protocol that was implemented for Windows NT, okay, which was decades ago. But NT structure is still being used today on your Windows environment, hence your file system NTFS. Therefore, legacy technology exists because we are upgraded over time. And old technology has to be carried throughout time in order for that to work. Understand? So NT-LAN Manager is still implemented in the back, even though your shadow password is supposed to be encrypted, right? And so now, again, if you're trying to crack a password, the more characters you have, the more time and resource the system has to put in to break that password. But if it captures the hash, it's able to use that hash and quickly identify what kind of password that is, because it's like this. I know that you have $1,000 in your bank account, and your bank account is, let's say, 12345. If I have your bank account, right, I go into your bank and I can quickly identify how much money you have in that bank account. So the hash allows it to identify and match, right, the password quicker compared to if that you don't have it. Okay. Any questions? Okay, man in the middle is an interception, right? Intercepts traffic through the network. And so the whole point in this is typically they do this with session hijack or some form of hijacking. So that way, you know, your traffic will never get to the intended destination. It will get rerouted. Okay. And so in this form of attack, they must decrypt your traffic because most web traffic, as you know, we use HTTPS, right? So they have to strip your encryption in order to access your traffic. Okay. So man in the middle is more complex because it has multiple levels. And when we involve encryption breaking, either you're using an effective tool, if not, you have to put in the amount of resources and time. So once they decipher or strip down your encrypted traffic, right, it must not alter the application because the way we design application is just to make sure that it checks it. So if you're using HTTPS, it would likely use TLS, right? If you're using an outdated version, that can be a vulnerable thing, and that's how they're able to strip it. But if you have an updated version, you have to take a look at, like, how you're routing and all these other resources, your traffic. So they already analyzed your traffic before they attempt it. So they recon you already, right? Because nobody goes in there blind and say, I'm going to give it a shot. Let's see if it's successful. Nobody does that, right? Because you might have a very small amount of time or window to execute something without acknowledgement of the user or the application, right? So 16. Describe the types of attack that's performed in the first phase of man in the middle. So in the first phase for the interception, they need to either do a relay or a replay attack. Two different things. A replay attack is when they intercept your data, right? Alter it, modify it, and then forward it. Sometimes this could also be part of the network base where your packets are modified or crafted, okay? So they would generate their own traffic with a crafted packet, right? That has altered data. A relay attack is where both parties initiated by the attacker. So they play the sender and the receiver. It's called a relay. So basically they become the fake sender and the fake receiver, right? And then they would relay the traffic information without manipulating it. So a way that I can intercept is I can impersonate your system, become the source and the destination, and impersonate the destination system. That's a relay. The replay is where they have to take the payload and modify it. Yeah.
Give an example.
So in a relay attack, let's say that all your system, once it logs onto the network, like let's say if I would reach out to the DHCP to obtain an IP address, right? To be connected, right? Or even remote access. So I'm coming in from the outside in order to access my work, right? I have to connect to my work network, right? So what the relay attack will do is, remember when they talk about rogue DHCP earlier? They would impersonate that server system, take your request, right? And then because typically the DHCP server, it has a forwarder. So take the forwarder, pretend to be that system, and then pretend to be the server system. So you completely intercept everything the user requests. Rejects the user, become the user, and send everything in. So impersonate that remote user completely. You understand? So it's like they would stand right in the middle of you and the real server. Pretend to be the forwarder in the real server. And then to the server, they're going to say, oh, I'm the user, this IP address. And all of that can be done with spoofing. But when you're coming into the network, it depends on the level of security that's in between, right? So if they have a lot of measure, when you spoof, you have to spoof for every step. It's kind of like you're wearing a mask. So let's say you come to the door of the school, you're wearing one mask. You're saying, I'm Dr. Wynn, right? You're wearing my mask. And then you go to another room, they might recognize you. So you got to make sure that that mask is still viable, right? So every step, and sometimes system interrogate. So they would examine other things. Does she walk the same way? So the system is looking for attributes to determine if that's real, right? So now we actually implement things like, oh, you can't just look at like the IP. You have to look at like the nature of the system, the behavior, everything else. So yeah, so a relay is when you basically relay as a sender and a receiver. Whereas a replay, you have to typically modify the actual traffic with the payload. So in an evil twin attack, I told you already, like a rogue AP, typically it's gonna use it to do this, right? I use a rogue AP, I intercept your traffic, right? I don't like you, I kick you out, right? I take your information, and I forward it to Instagram, Facebook, your bank, school, whatever, right? So you see those two come together. All right, next question. Sorry, this is a little longer. So, but I'm trying to keep time so you can finish one and work on two. Describe the types of attacks that can be performed in the second phase of man-in-the-middle attack. So man-in-the-middle, not only that you have to do those initial phase, which is replay or relay, you are going to have to spoof, right? We have to spoof fake certificate because when you go to a secure website, it's going to have a real certificate, right? It's going to say that this certificate validates that I'm secure and you are connected to me. So your browser is going to check that certificate and say, you know how sometimes when you go to an unsafe website, it tells you your connection is not safe. Click here to go back to safety, right? Chrome does that. Everybody designs their browser to do that. But so if it doesn't have a secure measure, it will be lacking that certificate. A certificate is just a file, okay? So they would create a fake file that tells the browser that whatever that they're visiting is safe, right? So that's called HTTPS spoofing. And then we talked about how there's the additional encryption tool that's involved. So HTTPS used two additional protocol, either secure socket layer, right? If you do some web development, you're familiar with this, right? Or if you learn, right? Or TLS. Secure socket layer implement the encryption to make sure that your traffic, your browsing activity is not visible, right? To the everybody that's examining you. So it applied the encryption. Now they can perform what's called the SSL-BEAST, which stands for Browser Exploit Against SSL TLS. This is a script that is used to intercept cookies. So what does cookie contain? Everything about your web activity, isn't it? Like what page you visited, your session information maybe, right? Sometimes credential, depending on the cookie. Now they're pulling a lot of your cookies because they want to see what you're seeing, what you're visiting, so that way they can market your products, right? But it intercepts your encrypted cookies that is used by your web application. Your web application uses encrypted cookies for what? Right? Like when you're paying your bill online with your bank account or your credit card, you need to have that encrypted sections with your application, isn't it? So that means that whatever that you have used for your sent cookie, they would be able to intercept it with the script. And then in the case that if you're using cyber blockchaining cookies, right? Cyber blockchaining, you see this with crypto. You guys know. I'm sure some of you know more about crypto than I do, right? Ultimately, it is a process to be able to have that encryption. It chains things together, right? Using operators. But anyway, so in that, you are going to have a little bit of time and resource requirement for CBC, okay? So these type of cookies are used for authentication token. These tokens are passed across the systems to determine your access level, okay? So if they're able to intercept that, then they're able to authenticate. So that's the ultimate goal. And then your hijack basically forged authentication that is passed between your user and your web application. And this is established with the TCP handshake. When you scan this on Wireshark in TCP session, you would see TCP has confirmation, right? It doesn't duck and go. So what it does is it acknowledge, confirm, and then send, right? So the handshake is then being compromised because the session seems secure. So it confirms that it's secure, so then it receives. So that's how you're able to get SSL hijacking. Let me see if I can see if there's some TCP going on over here real quick. Well, I can show you. No, it didn't see anything. I just have a bunch of UDP traffic. UDP is just like, it doesn't confirm anything. It just sends whenever it's available. So user datagram, you typically see that with like DNS traffic, streaming or accessing like media based like music or video online. What I call dump and go. Okay. 18. What type of downgrade attack consists of forcing the web browser to rely on the old weak hashing algorithm? This is known as sloth, SLOTH. Secure losses from obsolete and truncated transcript. Such a long name. So it forces your web browser to go back to its weak hashing algorithm. You know, hashing is used with encryption, but it's used for just integrity. However, in this case, you would have a sloth. And this is not too common anymore because browser design now has more secure capability in how they created these browser, but sometimes it does. If you have outdated systems, sometimes that happens. Let me run this and see if I can capture some traffic. Let me generate some traffic too. Let's see if we can visit. Would we open Canvas? So here you see some TCP right here. I'm going to show you what we talked about. So, when you scan, right? Remember we just talked about TLS and SSL. When you see typically you would have like HTTPS. That's going to come down as port 443. You can see that there. You see how there's an acknowledgement? So the first step with TCP is that it's going to say, hey, are you there? Right? And that's the other system's like, hey, I'm here. Let's talk. So you see some acknowledgement happening there, and it's a four-way communication, right? So subsequently, after that initiated state, you're gonna see the TLS happening. So whenever you run secure data through HTTPS, you would see TLS the version number. So when I scan this, I can see, right? Or if it's SSL, you're gonna see SSL. A lot of companies now transition to TLS, and you want to use the latest version because they fix the issues with the actual protocol. So you see some of that happening there with TCP. So when you're opening websites, things like that with HTTPS, you see acknowledgement. And then if you have data exchange, like you're using the web, submit your bill, etc., you often see additional things. So with that, what I want to do is come back to this. So denial of service attack is about, so SSL stripping, hijacking, and beast is on page 5 and 6, right? And then downgrade attack, there's a lot other downgrade attack that's involved in that, like Poodle, Freak, so you can read a little bit more about that. But we're going to have a chapter on just man in the middle and injection. Denial of service attack is following that. This is a way that they can take up your resources and your system just becomes unavailable. Earlier I talked to you about ping someone to death. That's a Smurf attack. It uses ICMP. So if you just broadcast lots of packets to the destination, it will become so busy that it can't respond, right? So you often see that network administrator, they would turn ICMP off on specific server. So you can't ping it. They would only turn it on when they need to troubleshoot. Typically it's on because we want to be able to troubleshoot throughout. So sometimes you see ICMP, and if you're using version 6, you have to use the appropriate service with that. SYN flood is a common thing. So remember we talked about TCP, right? You have SYN and ACK. Acknowledgement, hey, I'm here, you can send. Once you send, you need confirm. So it does a synchronization in the sending, right? So what happened is what the attacker can do is they can send the request for the connection after the acknowledgement had happened, right? So it creates that three-way handshake in the network. And so if they keep doing that continuously, and it's a simple script, you just have it loop continuously, right? So if they launch the script, you write it in Python and target a specific server, then you can see that it's going to keep targeting that, right? It keeps trying to synchronize because the server has to synchronize to submit data or to send data. So eventually it's going to get bogged down and it becomes unavailable. So it's just a way to send continuous requests. And so it's going to get busy and no more, right? So that's a way that they can also, this is very common for denial of service attack, is a SYN flood, okay? And so when you look at that on the Wireshark, you're going to see TCP, SYN, instead of acknowledgement that you saw earlier here, it's going to come from that source continuously. Like I said, if you have appropriate security measure, it's going to block that after so many packets, right? Drop. Terminate that connection, and then you can investigate. So when you capture, you're going to see that. Okay, so answer for 19 is SYN flood. Let's take this down. And then lastly, number 20. So how does an attacker bypass network access control in the network? So just like wearing a mask, right? How do you bypass security guards or, so they have to put on the mask, which is a way to spoof an IP coming in from the router, external network. And then once they're inside, they gotta identify with the physical system, which is the media access controller address, which is your physical address that is given to the network adapter. So if I want to attach to a specific segment of the network, I need to have the allowed MAC address because we all MAC filter. You guys do that at home? So on your access point at home, you can create a list of MAC addresses of the systems that you know that can be connected, right? And that's what we call a MAC filter. On Apple systems, you can, or devices that are not Windows, you can refer to that as UID, right? You can look at the actual ID. Your router, once the system is connected, it keeps a record of that, the IP address and the IP, right, for resolution purposes. So you can create a list of who can be connected. And then your friend comes over, even if they know your key to your access point, they won't be able to connect, right? You're gonna have to update your list. So that's how we can control who's connecting. We MAC filter. So if you spoof it, you gotta make sure that that MAC is on that allowed list, right? So how do I know? Well, research, recon, that's the key. So you started to see who's connecting, which system scan. All right. Any question? Okay, I'm gonna stop here.